page 9. Thanks. I'm going to go through some of those answers, or all of the answers with you, but we'll make sure that some of them with the different angles that you're pretty confident about drawing a triangle correctly. Because the location of where the angle goes and the side that they give you go are pretty important for side-side angle. The others, it doesn't matter. But when it's side-side angle, the way you have your picture drawn is very important so that it's set up correctly for you to find the parts that you need to look at. So today we're going to work on trying to determine the number of triangles, but then go back to finding the pieces of the triangle using the law of sine. So taking yesterday and Tuesday, trying to combine it together. So for the first two problems here, both of these use angle A and side B. So if you were making a sketch, there we go. It doesn't matter what letter the angle is that they give you, it always needs to go on the left. So they give me angle A must go on the left side, no matter what. If it was angle C, it'd have to go on the left side. So any angle they give you must be on the left. And then it is 47 degrees. Across from that is always its matching side, which is 10. The other side we were dealing with yesterday was side C. This one here is side B. That must be the side that attaches with the angle. So the other side they give you has to connect with the angle. So here is 15. So when you look at your diagram, every diagram that you're drawing should look exactly the same. Technically speaking, if you start on A and move clockwise, you have angle, side, side. Technically. Angle, side, side. Like when you're looking at your drawing, that's what it should look like. If you want to go counterclockwise, because you don't like saying angle, side, side, we have side, side, angle. But every picture should look exactly the same way, no matter which three variables you're given. Brandon, how do you determine if a triangle exists after you have your picture drawn?
You use what we did yesterday.
What do you have to calculate?
Well, you have to calculate the height.
And how do you calculate the height of the triangle? Which is technically this line that goes down, so that's the height. How would you calculate that?
Sine for 15 times the sine of 47.
Yeah, so you're taking the other side, because that's really the hypotenuse from the height. So that's 15 times the sine of 47 degrees. And Brandon, that is?
That is not written down on my paper.
Chelsea?
10.97.
10.97. So you have the height calculated. When you're comparing, the first comparison I would suggest making would be the side matching the angle. So side A matches angle A, and I would compare that with the height first. And Brandon, how does side A compare with the height?
A is less than the height.
And if it's less than the height, what does that mean about the triangle? It doesn't exist. That's why I would make the comparison with the height first, because if the height is bigger than your side that matches the angle, then there is no triangle, you're done, there's nothing else you have to compare. It has to at least be equal to or bigger than the height, or the A value has to be equal to the height or larger than it for a triangle to exist. So number 1 has no triangle, because the height is slightly bigger than the side approximating. So number 2, there should have been 2 triangles. Once you calculate the height, it's 6.69. And A is bigger than the height, so now I know I have a triangle. But the other condition, the A is less than the other side. And when you have those 2 matching conditions, you will have 2 triangles. And we'll talk about how they're created today and how you can find for all the pieces of those 2 triangles. So you need both conditions, less than B, bigger than the height, for the 2 triangles to exist. Letter number 3. So this one's a little different. What type of obtuse. So if you're drawing a picture and you have an obtuse angle, it better look like an obtuse angle. So this is 102 degrees right here. It's on the left even though it's angle B. So David Lucas, I had in 7th period, and he said he went through the whole sheet and changed all the angles to A and every side to be A and C because that's what we worked with yesterday, and he just thought that he was keeping it consistent and doing that for every problem, which is fine. But if you don't change the angle, make sure that the angle goes on the left side. So angle B is now on the left side. Across from angle B would be side B. Attached to angle B is the other side, and that's 35. This doesn't get an angle side. There. So when it's obtuse, the height is outside of the triangle, and it is irrelevant. You don't need to find the height if it's not inside of the triangle. The only thing you're comparing is the side that matches the angle. So angle B means I'm looking at side B, and the other side that's given is A. Cade, how does side B compare to A? So what does that mean about our triangle? Yeah, so there would be one obtuse triangle. As the given angle is obtuse, therefore this is going to be obtuse. Question. So number 4, again gives you angle B. So if I was drawing this, and that's like the important part, I'm putting B on the left. 65 degrees. Across from it is side B. Attached to it is the other side, and that's this here. Again, that's an A. So I still have angle side side, even though it's letter B. Still have angle side side. When you calculate H in this one, I have 12.7. The side that matches the angle is B, and B is less than 12.7 because it's 12. So again, this is no triangle. I just want to make sure that you can kind of see how the letters are working based off of the angles that you're given. Questions? Doing okay so far? So number 5, I sent through remind. No wait, we did number 5 together. See, I was like smart by the 3rd time I had the class. I was like, let's make sure I save time to go through one together. You guys got lucky. Number 6 should be no triangle because the angle is obtuse, and those sides are equal. So they are equal. This side is 41. Here's side C. And this side here is also 41. But it is never going to be long enough to attach to this side. It has to be bigger than it. Equal is not enough because of the angle is so far over that the side has to be longer in order to connect. Brandon?
Now, if we were doing side angle side, would that be
Then it would work.
isosceles?
Side angle side is good to go. It works every single time. Side angle does not. So this does not work because they're equal and it must be bigger than. So this is no triangle. Must be bigger than. If it was an isosceles triangle and my angle was different, it would be fine. But that would require the angle to be acute, not obtuse. Number 7 should be 2 triangles, and number 8. So both of them are 2 triangle cases. Number 9 is 1 triangle, and then number 10 again gives you angle B. So I'm putting angle B on the left. Here is 30 degrees. Across from it is side B, which is 4. Attached to it this time is side C. Anybody find the height for this one? Jenna, did you find the height? It's 4. How does the height compare with side B in this case? Yeah, they're equal. So B is equal to the height. What kind of triangle do you have? Not quite. A right triangle. So when it's equal, forget the T there, that means really this side here is coming coming straight up and down. It is the height of the triangle. So it gives us our right. That was the second one we did yesterday. And then number 11 is the last one that is side-side angle. That is an obtuse angle. 94 degrees is just an obtuse angle. And side C matches angle C, and that is greater than A. So that's one triangle, one obtuse triangle. Questions? So 12 and 14 were special because 12 and 14 are what types of triangles? What do you have in 12 and 14? Yeah, you got side, side, side. And we were working with side, side angle yesterday, not side, side, side. Side, 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 there's something special that you have to think about because there is a theorem that shows why you have one or you don't. Kate, what would that be?
Isn't it that if you add any two sides together, they have to be bigger than the third side?
Yes. Do you remember what that theorem's called? I was counting on you, Kate.
I'm sorry, I don't.
I forget what it is. And I didn't
Oh,
see
isn't it like the side addition postulate, something like that?
Oh, probably.
Yeah, I think that's what
The
it is.
name probably changed 5 times since I've been teaching because every book has a new name. But something like that. But if you take two sides, when you add them together, any two sides must be bigger than the remaining side. So, Brandon, what does that mean about number 12?
It doesn't exist.
Why not?
Because 4 plus 2 is less than 2.
If you take the smallest two sides and add them together, that must be bigger than the remaining side. Well, 2 plus 4 is 6. 6 is no way bigger than 10. So therefore, there isn't a triangle. So side, 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 you were told, and this is true, I'm not like switching this. You cannot use side, side, side for triangle congruency because not every triangle would be a triangle with side, side, side. So not every set of, or triples of sides. Pairs, not pairs, triples of sides. Brett?
Now, the more difficult way to be would be to add a 4 squared plus 2 squared to see if it equals.
Correct, yes. So we could do the Pythagorean theorem for all of them and make sure that it works, yeah. But not necessary. You can take the two smaller sides, make sure it's bigger than the third. So number 14 does work because the smaller two sides are 8 and 10, which is 18. 18 is bigger than 12, so you do get a triangle here. But it's not side-side angle, so like we couldn't solve it using the law of sines, but it's just kind of getting you to think about does a triangle exist. The one over here that I skipped, you're given angle B, which is 73 degrees, but you're not given the side across from it. Instead, we're given A, which could be here or here. We'll say A is here. And you're given C. What kind of triangle would that be, Michael, based off the way things are labeled? Yeah, ooh, listen to you. You're like throwing out all these fancy names. Yeah, it's a scaling. I was just looking for side, angle, side. You're like throwing out some good names and remembering those geometry days, huh? Sadly. So, Brandon said about side, angle, side a little earlier. Side, angle, side will always give you a triangle. You can use it as a triangle congruency statement, just like angle, angle, side. So if I had side, angle, side, if I had angle, angle, side, if we had angle, side, angle. Any of those three always gives you a triangle, no matter what. So you will have one triangle every single time, and only one triangle. The only time that it changes would be the side, 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 or the side, side angle. That's when we have to start looking to see if there's a triangle or not. So number 13 is good to go. It's side, angle, side. You always get a triangle with side, angle, side. Questions? How'd you do? Okay? Brandon? Well, because you didn't find the height.
Yeah, exactly. But if I do that, then I'll be back.
Good. Okay. So today we're going to kind of summarize this side angle situation. And we're going to go back to the law of sines and try and find the pieces to pull it together. All the triangles you'll deal with tonight are side angle. So anytime it's side angle, you have to do the little test to make sure you have a triangle. Because if you don't have to solve the problem. Kind of nice. So work through the little comparison, no triangle done, work to the next one. But when there's two, then it's a little more work. So we're going to work through a problem that you've got two triangles. But if you just flip the page in your packet, Day 3, section 6.1, still on the law of signs, but we're talking about specifically the side-side angle situation, which we call the ambiguous case. What's ambiguous mean? Kate?
Isn't it when something can have like two meanings or like it's not clear?
Yeah, not clear. So it could have 2 meanings, it could have 3 meanings, it could have 4. In our case, there are 6. So the ambiguous case are all the options that you can have with side-side angle. And it's organized in a nice little chart for you. Acute angle is the top one versus the obtuse angle, the one underneath. But it's called the ambiguous case because side-side angle works sometimes, and other times it doesn't work, and sometimes it gives you 2 triangles. So it's its own special name. Just to kind of review, the acute angle is based off of whatever is given, not what you find. So you're using the fact that you're given an angle that's less than 90 degrees. In this diagram here, it's using angle A, and notice angle A is on the left every single time. If it's B, you're going to write B on the left. If it's C, you're going to write C on the left. The other side that they give you is side B, and yesterday we used side C. So just above, as a reminder, I'm going to just kind of write A is the side across from the angle, because it doesn't have to be A, and B is the other side. So the most important thing with drawing side-side angle is setting it up correctly, drawing the right picture. So if you look at the first picture, it doesn't make a triangle. Why would you not have a triangle? So thinking about all the problems in the worksheet, the 6 different ones that we tried to graph, Virginia, why would you not have a triangle? Right. And that is the only condition that you need to know. If there's no triangle, A is less than H. You're done. Doesn't matter anything about the other side. So if A is less than H, there is no triangle. The second one, it actually has it written in the picture. If A is equal to H, then it's a right triangle. Again, it doesn't matter what the other side is. If they're equal, then you have a right triangle. So those 2 cases, you're just relying on H. Anytime H is bigger than the side that matches the angle, no triangle. If it's the same, then you have a right triangle. The other 2 are slightly different, and we have to think of both cases. In both of these, A is bigger than H. So pretty much it has to be equal to or bigger than it for a triangle to exist. If there's one triangle, it's because A is also larger than B. It's too big for me to pick up a second triangle because if we try and kind of pull the value inward, it's going to cross over that baseline and it would make a triangle. But in the last one, if A is less than B, then we would have 2 triangles. And that was number 4 yesterday. So we took the ruler and it connected out here, but then we were able to pull that ruler in, and the side A was short enough to be able to connect and make a second triangle. Questions? And then the other 2 options, the height doesn't matter because it's obtuse. So your given angle is bigger than 90 degrees. If A is less than B or equal to it, there is no triangle. Even if it's equal, it's not going to be long enough to connect. It must be bigger for one triangle to work or to exist. So what I'd like you to do is look underneath. And it asks you to determine how many triangles there are, and then it says to make a little sketch. So if you make a sketch first, that's fine, totally up to you. But see if you can just determine how many triangles exist. There are 4 of them. So when you flip it over, there are 3 more. So just try and work through, kind of make your condition, find H, right, Brandon? Yep. Find H, draw yourself a little sketch, determine how many triangles exist based off of the 6 different conditions for this ambiguous case. So when you're finding H, you're taking the other side times the sine of the given angle. Make sure you look, is the angle acute or is it obtuse? Again, all you need to kind of look at is those conditions. After you have your conditions, determine if you have 1 triangle, 2 triangles, or no triangle. Did you talk about it today
He did.
in German?
Yes.
How do you find it?
It's not right.
Able?
Everyone got an A for doing it.
It's a different world over there. It's foreign language.
Well, we usually don't do that. It was
Oh,
just
okay.
like, it was show and tell. So.
Gotcha. Michael, what'd you get for H for letter A?
Oh, I got 8.0.
So, what'd you say about the triangle?
I said 1 triangle.
So, side A is the side that matches the angle. It is bigger than B, and it's also bigger than the height. So, the key thing is it's got to be bigger than the height for a triangle to exist. So, that one would be 1 triangle. In letter B, Brandon, what do you have for the height?
24.9.
So, what do you say about letter B, Brandon? Why not?
Because A is less than the height and is less than B.
So technically, if I wanted to have a semi-accurate drawing, I would have a little side that isn't connecting to make the actual triangle. And that's because 15 is A, way less than the height of 24.5. Also less than B. Key thing is it's less than the height. For C, that's an obtuse angle, 110 degrees. You don't need to calculate the height whatsoever. So you're just comparing the side that matches the angle and the other side, and 15.2 is definitely less than 20. So it's not long enough to connect to reach, again, this would be no triangle. So you get those for your homework, woohoo, you're done, move on to the next one. You don't have to find any missing parts because there isn't a triangle to find the missing pieces for. The last one, we have 31 times the sine of 20.5. Chelsea, did you get the height for the last one?
It's 10.9.
10.9. So how does A compare with the height?
A is greater than
And A is
less than B.
less than B. So how many triangles would we have?
2.
2. We're going to work through this one. Of course, we'll do the one with 2 triangles. So when there are 2 triangles, I'm going to kind of switch my diagram a little bit to make it a little more exact looking. I only have the pieces written that go along with the problem. So B would mean angle B is over here on the bottom right, since side B is attached on the other side. That leaves me with angle C at the top and side C down here. So with the 2 triangle case, what is happening is that the ruler that we used yesterday, that side, is connecting over here to make this big outside triangle, but then if you pull it inward, it's also connecting to making this little triangle over there. The side of this obtuse triangle, this little skinny triangle on the side, if this is length A, this also has to be length A. Because it's the same distance, I'm just taking that ruler and like rotating it a little bit to form a second triangle. So these two, even though I don't have it drawn proportionally correct, are the same side length because you're using that same length A to make both triangles. So we're going to see if we can just kind of go through solving the parts of the triangle. I'm going to work on the big triangle first. So I like to start with the big triangle. I'll redraw it a second time just to have it redrawn. You don't have to redraw it a second time, but I just want you to kind of have a visual that looks a little neat. So we have angle C, angle B, and here's side C. So taking you back to Tuesday when we first talked about the law of sines. The goal is to find the missing parts. How do you find the missing parts of the triangle? We have side angles, so we have 3 pieces that we know. Virginia, how would you start finding some of the pieces we don't know? So we could find C. Is that the one we can find first, though? Which one do you have to find first? Angle.
Angle B,
Why angle B?
because you have the side of B drawn.
Right. So in order to find the side or the angle, you have to have its matching part. So I have to have either the side or the angle in order to find one of them. And we have side B, but we don't know angle B. So to start with the law of sines, we're taking the side 12 over the sine of 20.5 because that's our pair that we know both portions. And you have to have that in order to use the law of sines. The other side that we have is 31, which goes along with angle B. So that's how I would start off with the law of sines. Since we're finding the angle, what do you do in the calculator whenever you need to find an angle? Michael, what would we put in the calculator to find the angle?
So I cross multiplied the 31 and 20.5, and then I divided that by 12.
Nice. So cross multiply, divide out by 12, and then the button you're pressing in the calculator is?
The inverse sine of that
Right,
value.
do the inverse sine of this value. Make sure you're plugging all of that in parentheses, even the divided by 12. That needs to go inside the parentheses. Did you get an answer?
I got 64.8.
Yeah, 64 point what?
0.78, but I estimated 0.8.
0.8, perfect. And that is angle B. So up here in the diagram, we've got 64.8. So you have to find that one first because you know its counterpart. You know the part across from it. Now, Virginia, how could we find angle C? So she said take 20.5 plus 64.8, subtract them from 180, and then that'll give you angle C. Anybody have angle C?
I got 94.7.
94.7?
Yeah.
So that's this up here. So we use the law of sine once, we then use the fact that it's a triangle, 180 degrees. And now we're gonna have to use the law of sines a second time, because we still need to get this piece down here yet. Brandon, how would that look?
Well, now that we know C, so I thought maybe we could do, 31 squared plus 12 squared equals C squared.
Is it a right triangle? No. So unfortunately, that only works for right triangles. What else could you do?
We just plug 12 over sine 20.5 equals x over 94.7 degrees.
Yeah. So you're gonna use that proportion twice. One to find the angle, second time to find the side. Then it's 34.1, thanks. So we have side C, angle C, angle B, and that's for like the big triangle. So looking at my diagram that I tried to make neat, but it's kind of neat-ish. I'm gonna label this here as 64.8. That would be the angle B that we calculated. So there are two triangles. We found the big outside triangle. But we also need to find the information that pertains to this little triangle on the side, because it says find all the missing parts, all the missing pieces. So any angle or side that's missing for either triangle we need to find. We have to decide how we can find that information. So I'm looking at this little skinny triangle on the side. And it looks like that. So we know that this is 31. This angle is still 20.5 because it's the same angle. And this side here is still 12 because the length of A is still the length of A. We just moved it inward to get a second triangle. How could you try and find another angle inside that triangle? Chelsea?
Wouldn't B just be the same as last time?
Kind of. We need to use it to help us find it. So this angle here can't be the same as that angle there. But it is the same as another angle,
Would it be the same as C?
not C. So this angle B here is the same as another angle A.
Isn't it the same as the C of the skinny triangle because it's an alternate? No,
Up here?
Yeah.
No. I think you guys were thinking similarly. Any other suggestions? Ben,
Is it one particular angle or is it,
one particular angle.
did we say A then?
No.
A?
It's not an angle that's listed.
A plus C.
Sabrina?
Is it maybe C minus A?
What is this angle right here? Virginia? Why?
Because it's triangle, so they're same on both
Yeah. So we're pulling out all these triangle words because these two lengths are the same, and I know they're not drawn to look the same, that's my fault. I tried, but I still failed. These two lengths are the same, so that means these two angles have to be the same. The sides are the same, the base angles are the same. So if I know that the angle connected to B is 64.8, and they're connected to each other, those are supplementary angles. So Kate, the other angle on the other side, right here for B, would be 180 minus 64.8.
Yeah, that's 115.
That's 115.2. So you need to use the angle that you found for B in order to find the other angle B. So there's like B1 and B2. At the top then, I now have this is 115.2. So to get the top angle C, we would take 180 minus 115.2 and the 20.5. And that leaves what left over for C? Brandon, what's left over? Sorry, I thought you had your hand up. Somebody have Kate? 44.2? 3. So that's the top little skinny angle up here, 44.3. So one more time, you need to go back and use the law of sines because we still have to find this little piece here yet because that's still C. So you're going to end up using the law of sines 3 times. You're going back to the original side of 12 and the angle of 20.5. But now I want to find C that's attached to the angle of 44.3. So it's unfortunately a big problem because there's 2 triangles that you're solving for, and it does require a little bit of work. The proportions are easy, but it's kind of getting the right pairs to match up together. So I think this is, what's the other one? 34, I forget. 23.9. You'll have one problem tonight that is 2 triangles and just one. I made sure to only choose one and not all of them. Please make sure that you're kind of referencing the notes so you can see how you find all of the little pieces. But you should use that proportion 3 times with 12 over the sine of 20.5. So that gets used 3 separate times just with different pairs of values. Questions?
Do you like cigarette box?
Oh, they're all right. I don't like peanuts.
I have like 4 of them.
Oh, yeah, I'm good, thanks.
Yes. My grandmother paid me
I have the
$20
homework from
to
yesterday.
Oh, perfect.